Hi, my name is Justin Gagel, and I'm with the CFAA, and today I'll be discussing concentration tables for general chemistry. I'm going to go ahead and read you a problem, and then after I read you the problem, we'll start working on it. Lactic acid, or HC3H5O3, is present in sour milk and gives sauerkraut its tartness. It is a monoprotic acid. In a 0.1 molar solution of lactic acid, the pH is 2.44 at 25 degrees Celsius. Calculate Ka and pKa for lactic acid at this temperature. Okay, so to start out the problem, we first need to write the equation down and then figure out what the problem actually tells us. So the equation for this will be HC3H5O3 yields H plus C3H5O3 negative. All right, so this is the basic equation. In the problem, it told us a pH value and an initial concentration. So these two things usually lead you to believe that you need to do an ice table. So we'll start out our ice table with just ice over here so we can see where we're going. Initial concentration for the acid is what was provided in the problem, which is 0.100. And say you put this amount of acid in a solution of water, initially there's going to be 0 of these two ions over here. So that's what it will be in I in these positions. The change in here, since there's nothing on the right side of the equation and it's all on the left, then you'll lose some from the left and it'll move to the right. And the mole ratios in this is 1 to 1 to 1. So you'll lose an X amount from here and gain an X amount on both of these locations. Equilibrium concentration is something we'll have to find from the pH which they provide in the problem. The formula for pH is pH equals the negative log of the concentration of H. And the concentration of H is what we actually need. So we can find that from the formula of concentration H positive equals 10 to the negative pH. And in this case, our pH was 2.44. So if you calculate this out using your calculator, you'll end up getting the concentration of H is equal to 0.0363. And if you include this in the equation, this is going to be your X. This is what you gain for the protons and for the anions and what you lose from the initial concentration of the acid. So our equilibrium concentration for the acid will be 0.0637. The concentration of each of the others will be what we just found as 0.0363, 0.0363. Okay, what it asked for in the problem was Ka. The formula for Ka is just like any other normal equilibrium constant, and it requires the multiplication of the concentrations of the two products divided by the concentration of the acid. So if you plug in the numbers from the problem above, you get this. And when that's actually multiplied out, you end up with a Ka of 2.07 times 10 to the negative 2. Now, to get pKa, whenever you usually have p of anything, it equals negative log of that number. So in this case, pKa will be equal to the negative log of Ka. And if we plug in the number we just got, we end up getting a pKa of 1.68. So this just shows some of the basics of concentration tables and how to get information from the problem.